Hi, my name is Valentin, and I work for JetBrains, a company which produces tools for other developers. Well, the most famous are IntelliJ IDE, I think, and the most important one today is RubyMine, which is Ruby on Rails IDE. Today, I'll tell you about a side project we're working on in our team for some time. So the question is, why do we need types in our programs? So why do we discuss whether we should add type annotations in Ruby language syntax or not? So for a start, I'll take my chance to tell in short what we are doing in RubyMine team and why typing is so important from our IDE perspective. The first and most fundamental and important case is symbol resolution. Well, let's have a look at this short snippet. We try to resolve the 2s method. There are so many of them in the project, probably in the huge project, there may be thousands of them, maybe not sure. And if we don't know the type of variable object, we don't know where to go, and we don't know how it is implemented. So that's where types are used fundamentally. The second one, which is interconnected with the symbol resolution and dependent on that, is code verification and bug prediction. So in this snippet, we try to resolve the project property in commit variable. And if we don't know what type commit variable has, we don't know whether it's a bug that we try to send the project method, or we just, well, our IDE can do it. Well, let's then annotate the property with the YARV annotations, and then everything's okay. So there may be false positives if we don't know the types. If there are so many false positives, the whole static analysis thing becomes useless. The third thing is code assistance, for example, completion, which suggests the right values in the right place and the right time. It speeds up the development, increases productivity, blah, 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 and maybe decreases the probability of introducing new bugs in your code. And the last thing, the last category, are more complex features like refactorings. So there is an example. We have an execute method, which I think kind of popular name for a method. And if we want to rename it, for example, to dispatch or something, well, this case looks easy, right? But what if they have another class with another execute method? Should we rename it or not? So if we have tens of such usages, I mean such methods with such name, how do we know which to rename and which not? Should we do this manually? So that's the question. So here I probably a little bit sold you RubyMine, but that's not my purpose here. And let's look at what real people, I mean other people, why do they need the types? And we'll talk about the second thing, namely bug prediction. So a non-IDE perspective. Do we have a good Ruby tool which helps to predict new bugs? Well, probably there is a famous one, which is RubyKaigi. I think it's the most recognized linter for Ruby. It has a good number of built-in community influence inspections called cops, which check your code. You can also add some team-wise preferences via custom cops. Well, that's a great tool. However, it's barely a full-fledged code analysis tool. So let's look at the following snippet. RubyKaigi bothers about code smells in the code. It suggests that the code lacks some spacing, that we should convert hashes to another format. However, on the last line, we can see that we're trying to send the downcase method for hash, which is absent. And the RubyKaigi can't find this. Can we do better? Yeah. So here there is RubyMine again. And it can understand that if x has type hash and we're trying to send the downcase method, then this is probably an error. Well, I'm sure this is an error in this case. However, RubyMine is not so sure. So why this warning is not in red color, but in gray? The reason is that Ruby dynamic nature, which allows creating beautiful DSLs, it impedes code analysis. So code is really difficult to analyze, and this is not fixable by static analysis, actually. Let's look at this example. Here, there is a method, which is a factory, which produces an object of some type, and the type depends on the value you're passing as a first parameter. Maybe, particularly in this case, we could understand that if we pass a photo, we can do some conversions and understand that probably we should use photo class. But what if, for example, this first parameter came from some YAML configuration? Then IDE and any other tool just doesn't have a chance to understand that. Well, how do we cope with these cases? Beware of bugs in the above code. I have only proved it correct, not tried it. This is a citation by Donald Irving Knuth, who passed his work to his colleague and warned him to recheck it. So there is a very important idea in it. You can't be sure your program works properly before you run it. So this may be rephrased in many ways. For example, you can't be sure your product works in production before you run it in production. So we prove it every day by running tests, by debugging, and by finding regressions in production. So it says that probably we should use TDD, but there is a huge problem though. By running a program, we check just a droplet of cases in the combinatorial ocean of possibilities. And which of these possibilities will backfire and break your code, you don't know. So there is another citation by Edgar Dijkstra. Program testing can be used to show the presence of bugs, but never to show their absence. So there are two problems. On the one hand, we can't have ideal static analysis tool because we need to run tests to prove something. On the other hand, by running the tests, we check only some cases. So what do we do? In Ruby, we have TDD technique being used everywhere, but we don't have a really good static analysis tool. Also, there is a problem with the coverage. Even if you have 100% coverage in your project, that doesn't necessarily mean that you check all the cases. For example, if you use some library, you don't check all the branching in that library. So this is sometimes called integration tests, so how to match all the outputs from your code with all the possible inputs from the library. I'm not sure that there are so many projects with ideal integration tests. So what can we do? We can run the tests, continue running it, and continue finding regressions in production. We can, after every commit, we can rewrite the whole code, sit with debugger, trying to understand what changed, prove that it is correct. And yeah, the thing that any of us does, we test in production. So can we strengthen our tests? Can we increase some kind of abstract coverage? Actually, by running, we only check the answers which we ask in tests. But during execution, there is so much more happening in the computer. And I think we should remember something from there. Let's try to combine the power of tests, which run many places of your code, and the capabilities of static analysis. There's an example, rspec matchers. Look at B method, which returns, has a return type depending on the input. So if there is nothing in input, it returns B. If there is anything, it returns equal class. And they have different set of methods. So let's if we execute the first two lines, we can try to write down the rule like this. So to the left, there are some inputs, and to the right, there are some outputs. So if we use it, then we can understand that b with one parameter will be of class equal, and that it doesn't have the comparison operator. Well, there is kind of outdated, still working demo in RubyMine, which shows how it works. So we have a resolution to dynamically created methods. So how this works? How could we find the method which is created by some instance eval or define method? First, we try to obtain the raw data, which are these rules. So the input types to the left and output types to the right. Then we try to transform these rules into some human-readable form and compressed, because human-readable and compressed form, because there is so much data, so many calls throughout the execution. And later, we can store these results somewhere, reuse it, and maybe share with your colleagues. So let's start with the first stage. Probably, if you have written a debugger for Ruby, you know how to use tracepoint. Well, it has many beautiful applications, and it can be used for debugging. I think Tenderlove has a great blog post about how to use tracepoint for puts debugging. But we'll use it in another way. So how does it work? There are several events in Ruby virtual machine, like calling the method, returning from method, raising an exception, and so on. And tracepoint provides the possibility to hook these events and execute any arbitrary code in these hooks, and also to access the variables, the data, in the context of the events. So tracepoint.binding is the way to get this context. And then we can get the method which is called or returned from. We can get all the local variables from here, the parameters, and so on. So to the bottom, there is a line. To the top, you see the foo method definition. To the bottom, we call it with one parameter. And there is the result of the execution. So there is a call event, and the variables values are integers 2 and 1. And on return, after the b variable was changed to a string, well, we track it, we find it, all's good. However, there's a problem. The problem is that despite the fact we passed only one parameter, tracepoint thinks that there are already two local variables here. So actually, it attaches after the point the default value is given to a parameter. Why does it matter at all? Let's consider another example. So this is a dynamically created foo, which has one parameter, and it has a default value, but we don't know which. Maybe it comes from YAML also. And there is a multi-assignment without a parameter, with the string parameter and int. So if they execute this and try to build the rules with the help of tracepoint, we can get two rules, that int goes to int and string goes to string. But now, how we know what does foo return if it gets no parameter at all? So this poses a problem, because not every time we can find the source of method, and not every time we can, even if we find it, we can understand what's the type of the default expression. So we need to go deeper and refer to another debugging possibility of virtual machine is disassembling YARV bytecode. Well, the output is very easy to comprehend. I think it's very intuitive, right? To the left, there's a column with the number of instruction. The second column are the instruction names. And trace instructions here are the places where trace point may attach, actually. So there are actually two disassemblations. The first one is for the top level, so it's method foo definition and its call. And the second one is for method foo itself. So we can see that the default value of 239 is assigned right before the first trace instruction in the disassemblation of method foo. So what do we do? To the red rectangle to the top, you can see the answer to this question. Actually, virtual machine stores the information about the number of passed parameters. And out of that, we can understand whether the parameter was passed and whether it wasn't. And then we can modify our rules to, well, as it was in RSpec matchers. So there was a rule that nothing comes to some class. So we can do this. Looks easy, right? So we'll use RB control frame T, which is a structure in Ruby C API which contains a pointer to the current instruction in the frame and instruction sequence itself. But the amusing thing is that the instruction we are interested in, the method sending, is located right before the one we're standing at the moment of call event. So we kind of need to backtrack, and yeah, this is almost easy. It looks like we didn't find a conventional way to do this, so there is a little black magic in our code. So I think I won't explain how this works. So that's it. This is the first stage. We use tracepoint to collect the data, and for the corner case, when we don't know whether the default value was passed or not, we just disassemble and try to do some weird stuff. For people who don't know how to write C extensions, there are some, I think, useful resources. Obviously, the most useful one is just reading the code, the most representative. But there is a Ruby C extension cheat sheet, the second link, which, well, helped us a lot. And not working cable doesn't help at all. OK, so we'll move to the second stage, which is transforming these raw data to a type contracts. Why do we need to do this? Because there is so much raw data that we couldn't store it, and we couldn't process it, and we couldn't use it effectively. Let's look at split method of string. So I just took from the documentation some usages, which is, I think, exhaustive example of its usage. And let's transform these usages to type tuples. So what are type tuples? Type tuples are these rules we're talking about. So the set of input types and the resulting output type. So there are no duplicates in these tuples, but still it's too much data. If I were doing this manually, I would probably transform these tuples into some kind of contract to the bottom. So actually this might be written in YARV, like param pattern, which accepts nil or string or regex, the param limit, which can be of type nil or integer, and return tag type array. But obviously we want to automate this process. So let's try to transform our tuples into such diagrams on how we can compute the output type given the input types. If we can follow the arrows in a way that we finish successfully, then that's some tuple we have in our database. Let's merge start and finish endpoints. And now this is called NFA, which is non-deterministic finite automaton. this is how regular expressions work, and how do we use it? This is kind of similar to roll and move games. So there is a map, and there are some tokens and dice, and you roll the dice, there is some number on the dice, and according to that number, you understand where you go from your current position to some another position. So let's look at the example. For example, we're trying to understand what will return split method given a string and nil. So there are two moves with string. Let's observe them. And on the bottom one, there is no transition by nil type, so we die here. And to the top, we successfully pass to the finish. But if the second parameter is string, we just can't pass further, and that means that there is no information about such kind of input types. So let's compress our automaton. Let's look at the equal transitions from the same vertex, because it is not convenient to check all of. Okay, let me return a little. So it's not convenient to check every time a set of vertices and whether we can go from there by some type or not. So let's merge the equal ones, and we'll obtain something like this. This will be called now DFA, which is deterministic finite automaton, because from every node there is maximum one way to go given some type. Now let's see that the marked nodes have the same behavior. What does it mean? Speaking formally, they accept the same language, which means the same sequence of input types will produce the same results for them. There is no sense in storing such duplicated information, so we can just merge them. And the last step is to transform the strange finish vertex with word in it into a normal vertex. So automaton looks like an automaton, and this algorithm is called automaton minimization. So this is a classic algorithm, actually. Looks like we won, but it's too early to party, because let's look at this example. This is a max function which accepts two parameters, probably of the same type, and it returns one of them always. So there are some usages, and if we build an automaton, a contract, with such rules, we'll obtain something not very pleasant. We can fix this. Let's go back a little and change the way we produce the type tuples. So for every type, let's introduce a kind of bit mask which represents the equality between this type, the current type, and some previous ones. So the bit is 1 is if the current type equals to some previous, and the respective bit is 0 if it doesn't equal to that previous parameter. And let's produce all type tuples with such algorithm. So if bit mask is greater than 0, then we replace the regular type with this mask. And we'll have this set of tuples, and still we can formally use the same minimization algorithm as we used before, and we'll get some, I think, good result for the same set of input. What happens if you decided to change your code, your usage a little, for the same method? So since the method is the same, it hasn't been changed. It should have the same contract, so it should accept the same types as it accepted before. But if we build an automaton for this one, it will be a completely different one, and it wouldn't accept previously accepted things. So we need to merge, be able to merge automatons, and we can do this. We implemented an algorithm which merges automatons into one which accepts everything which every of the merged automatons accept. And runtime of this algorithm is linear, which means it's fast. And, my God. There is a little problem still that there may be multi-edges. So between the two vertices, there may be a very big number of transitions of different types. What does it mean? It means actually that the method does something with that parameter which might be done with different types. So it might be one class, it might be a superclass for a set of classes. It might be an interface, but we don't have interfaces. It might be duck types. So the unresolved problem yet is how to transform these multi-edges to one edge with some interface in it. So this is to be solved yet. There is a little demo on how can we produce contracts. So we're running this code with our type tracker, and we have an intention in our IDE which allows for creating type annotations right in the, oh, I'm sorry, I just couldn't. Which produces the type annotations in the comments for the method. Note that there is only one usage of equal method with date class, and note that formally we can't know that this method can return false given dates, so we add one more usage, we rerun the code, and yeah, that's it. We can produce type contracts in the comments. So the last step in our project is to understand what to do with all this data, with all these contracts. And this one more question is how to run our code in such a way that the contracts which will be produced will be of good quality. So how do we collect the data? You have a project, and probably you have some tests for that project. So run your tests with the type tracker, and the type tuples will be transformed into type contracts, and you can use them later. However, one more question is how to get better results, how to get better contracts. Well, the answer is simple: run more tests. Because the more tests you run, probably the more different call sequences you'll have for the same methods. And the most important question is how do we collect the data in such a way that the contracts produced by this technique will be the same as if we produce them by analyzing the contents of the methods. So the answer is, yeah, straightforward. You can cooperate with others to run even more tests for the same stuff. So what does cooperate mean here? There are such things as gems, which everybody uses. One gem of one version can have tons of usages in different projects. And each of projects using this gem actually provides some unique way of calling methods from that gem. So if that project will run their tests by producing the contracts, and if later we merge all this data, this particular gem-related data, into something monolithic, I think we may have a good annotation, truthful annotation for the methods in this gem. So what do we want? We want to build a global library network where everyone is encouraged to share their runtime data to be merged into a global database. So the merged annotated libraries then can be grouped into several packages which you can download, for example, and use for your tooling. We'll speak about tooling a little bit later. what are the profits? The profit is that with time, as you will modify your project, as more users will start using this project, as more users will upload and merge their data into global database, the controls will become more and more complete. And also, if there is a new gem or new gem version, or if there are any changes, nobody needs to annotate the newly created methods. Nobody needs to modify the type annotations in the code because they are generated automatically. So I think that's cool. And I would like to emphasize once more that by merging our data, we're effectively merging our tests and merging our coverage. So we improve the capabilities of static analysis based on that data. And yeah, talks cheap, show me the code, yeah, and stuff. This is our repo, which is JetBrains/ruby-type-inference. It consists of several parts. One of these is argscanner gem, which is uses trace point to collect the data. There is a special server which you can run, and it will receive type tuples from argscanner and produce type contracts from them and write them down into a database. And there is also an IDE plugin, I mean IntelliJ IDEA or RubyMine plugin, which tries to use this data to improve the code static code analysis. So please ask your questions, file issues, share your insights, criticize our project because we need your contribution and need your opinion. And I'll speak a little about tooling, which we can have with this. Of course, there may be some IDE goodness, which I was talking in the beginning of this talk. So every part of IDE capabilities may be improved because, as I said, the base for all the features are knowing the type of objects, the types of methods which we call, and so on. So if we use better data, we can have better results. On the side, we can use a better code verification means. Now we don't have a good static analysis tool, standalone code analysis tool for Ruby. I would like it to appear. I think we can try to use this kind of data to cope with dynamic nature of Ruby. And my final thought is that I think it can be used for guided optimization for MRI because just look from the perspective that there is some type information which can be placed in a file next to your project. And if virtual machine could use this data for type inference, it can speed up virtual machine greatly, I think. But I haven't tried to do anything with that, it's just my fantasy. So, yeah, I think if we succeed with this project, it may solve some problems which lead people away from dynamically typed languages, not only Ruby. So a major part of programming success is the tool set they use. And I think developer happiness is not only about the language, it is also about the tools we use. Thank you.
Thank you very much. We have 5 more minutes, I guess. Yes. Any questions from the audience? Oh,
hello. So thank you for a great talk. So I have a question. So your idea is collecting the type data from the all of the world. So many types. So maybe so many types are collected. So for example, using Rails. So they are making their own application and their own types, classes, and the types should be so many signatures, I think. So for example, so render, so each application has each own controller or something like that, and the type signature will be many and many. So what do you think about that?
Yeah, so this is what I was talking about. Let me find the slide. Yeah, so this is to be solved yet. We are aware of the problem, but if every, for example, Rails application has its own controller, probably they have still many things in similar. So they inherit the same stuff from Rails. So if we understand, for example, we can replace, in this case, the numerous controllers to just some base class of controllers, and it should work.
Yeah, I agree. Okay, thank you.
So you were talking about using tracepoint to track the types within tests. I know tracepoint tends to have a bit of a performance impact. What kind of an impact have you seen in your test suite? Like, has it slowed down significantly, or?
Yeah, so the slowdown is very significant right now. It's tens of times of slowdown. And yeah, this is definitely not to be run in production. But the thing is that the idea is to run your tests once, and then all the data you collect, it is stored, and you can reuse it anytime later. So yeah, once you'll need to wait hours for tests to complete, but then you'll have some type contracts to use.
Thanks.
So my question is about maybe somewhat similar to the Sasada-san one. So when you collect the type information across the application worldwide, so in Rails application, there may be a lot of name collisions. So a lot of applications have account model or user model, accounts controller or users controller. So is there anything wrong in that case?
Okay, so we can split the data we collect into two categories. The first category is your own code you have written, and you definitely don't want to send it to the server for two reasons. The first reason is that it's your code and only you need it. The second reason is that it is mutated over time. So there is no versioning, probably. This is just a repository. And if you change something, there will be a different, maybe contradicting results. So yeah, this won't work. But the second category are gems. Gems with fixed versions are fixed. And all the contracts which are produced for them may be freely used by everybody if the gems are public.
Yeah, I mean that the method signature of the gems may contain the application-specific type names.
Mm-hmm.
Is it?
Okay, it is not addressed yet, too. However, I think it's possible to anonymize such stuff. And again, if many projects will run this, I think there will be many private classes in the contract which must be compressed into some interface anyway.
Yeah, thank you.
Mm-hmm. Any other question? Okay. Okay. Thank you very much. Thank you.